So in this first video on similar shapes or similar triangles or similarity, we'll be looking at what is meant by the word similar, how to spot if shapes are similar, finding the scale factor, and finding missing lengths on similar triangles. So as mentioned, similarity or similar shapes or similar triangles has got many kind of names. So depending on what it's labelled as on your revision list or on your sort of syllabus, it's always important that you know between the three things. So when shapes are similar in mathematics, it basically means that one shape is an exact enlargement of the other. Now the word enlargement can seem somewhat deceiving because often when people think of the word enlargement, they always think that you're always making something bigger. However, that is not always the case. Just like when it comes to multiplying, is that when the biggest misconception or the biggest error that people think is when you're multiplying the number by another number, you're always making it bigger. However, that's not the case when you are multiplying by either a negative number or you're multiplying by a number that is less than 1. So don't always automatically think that when you're enlarging a shape that you're always making it bigger. Now what does depend on the enlargement is its scale factor, and that's basically how much bigger or how much smaller you are making a shape. So if the scale factor is bigger than 1, then it means that you are making the shape bigger. If the scale factor is between 0 and 1, then it's making the shape smaller. And if you're dealing with a negative scale factor, then what that often means is that you could necessarily be making it bigger or smaller depending on what the actual digit of the negative scale factor is. But the negative sign basically means that it's being rotated in a complete opposite direction. Now that negative scale factor is not something that really comes into this particular topic. That's more seen in higher level transformations and enlargements, which is a completely separate topic. So when shapes are similar, though the dimensions or the lengths of the shape might be different, the interior angles do not change. So that's something that's really, really important, particularly when establishing some of the basic questions in this topic where you're just seeing which shapes are similar. Now, when I'm teaching this kind of face-to-face, and how I kind of relate this is through photocopying machines. So if you've ever been to reprographics or where they do the photocopying in your school or office, let's say, that you can obviously the photocopier makes things smaller. So things that were A4 can be shrunk to A5 and vice versa. Things that are from A4 you can enlarge to A3. Now, an A4 sheet of paper is a rectangle size. Now, if you obviously make that smaller to A5, let's say from A4 to A5, that the interior angles will always stay 90 degrees because obviously the physical shape hasn't changed. It's still a rectangle. So if you were to have like a shrinking gun and you were to zap a triangle or an isosceles triangle, obviously you can make that triangle bigger or smaller, but it will still remain an isosceles triangle. So the angles would stay the same from its original shape. It's a really important factor that you kind of need to remember. So with basic questions, basically all you're doing here is checking to see if shapes are smaller. So just as a quick refresh, which is worth noting in your notes, that if shapes are similar, then the dimensions of one shape must all be increased or decreased by the same scale factor. Also, if shapes are similar, then the interior angles will always be the same. So let's just put a bubble around that, and I just spotted a slight spelling error. There we go. And another top tip is when you are deciding whether shapes are similar is to redraw the diagrams if they're not in the same orientation. So for example, if we just take some of these shapes at face value now, I always say that to do well in maths, it's about 65% knowledge and 35% common sense. So when deciding which shapes are an enlargement of one another, obviously looking at the shapes that we've got on your screen, obviously A and C are not going to be the pairs, simply because they are two distinct different shapes. So A is a triangle and C is a trapezium. So if we just look at face value of what similar shapes we have got, so just as an idea, I can see that A is quite similar to D and it's also quite similar to K. Now I can kind of distinguish that A is definitely not going to be the same as D and K, simply because just looking at the face value, although the measurements are not going to be accurate, so I'm not going to get a ruler, but using the squares that you can see on your screen, A is clearly what could be perceived as a isosceles triangle, an equilateral triangle rather, whereas D and K are quite obviously an isosceles triangle. So I can kind of eliminate that, but I'm not going to take the risk. So the next other sets of similar shapes I can see rhombuses. So we can see that we've got B, E and J are going to be similar. I've also got a set of trapeziums in which I've got C and F. And I've also got some right angle triangles, which if I do with a different colour, in which my right angle triangles are I, and I've got G, and I've got H. So you can see there that I've got a range of particular shapes, and I think I'm missing one out. Am I missing one out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we have 11 letters. Yeah, so always worth just doing the basics and making sure we've got this there. Now, to check to whether shapes are similar, obviously we haven't got really time to measure the interior angles, because obviously the interior angles should be exactly the same. So what I mean by that is, if I look at A and B, that if A and D are similar, then this green angle, this angle will be the same as this angle here, and this angle on D will be the same as that angle there. So I could measure the angles, and if they're all the same, then they're definitely going to be similar. And I'm just get rid of all that shading. So instead what we're going to do is we're going to look at the lengths and see if there's any comparison towards this. Now, what you want to try and do now, in theory, you should be looking at all dimensions of each of the shapes. So you should be measuring all the sides. So if it's a triangle, you measure all 3 sides. If it's a quadrilateral, you measure all 4 sides. And if it goes beyond that, like a compound shape, then you measure the end. But for this, what we're going to do is just look at the basics. So what I'm going to do is I'm going to compare for the first set of shapes, which is A, D and K. I'm going to look at the base, and I'm going to look at the height. So I'm going to compare the base, and I'm going to look at the height of each triangle. Now, in terms of the orientation, we can see that K is one that's kind of been rotated. So what I might want to do is kind of either on a side note, or maybe in my head, is just rotate that shape so it's in the same sort of position as A and D. So if I look at looking at A, D and K, if I look at the base of this triangle, that's got a base of 3 and the height is 3. If I look at D, that's got a base of 4 and a height of 6. And if I look at K, that's going to have a base of 2 and a height of 3. Now what I want to do is, you can see here that with D and K, that the bases and the heights are completely different. Whereas with A, the base and the height is exactly the same. So I know straight away that A is not going to be a perfect enlargement of D and K. Now, to check whether this is the case, well, looking at the bases and comparing the 2 bases, so I've got 2 and 4, so you can see that 2, if I double that's going to give me 4, and if I double 3, it's also going to give me 6. So the fact that there is a common factor or a common multiple that goes from these 2 sets of dimensions, it means that they are similar. So then one of the answers, if I write the answers here, is that D and K are similar. So if you look at the next shapes, so this time let's look at B, E and J. So B, if we look at the widths of each of the rhombus, that's got a width of 3 and it's got a height of 6. With E, it's got a width of 3 and a length of 5. And with J, that's got a width of 1 and a height of 2. So basically I'm looking for where the width and the height is basically twice as big. Now with E, you can see that here I've got 3 and 6 and I've got 1 and 2, and here I've got 5 and 3. So you can see straight away that E is not similar to B and J, because obviously the dimensions aren't perfect. So for example, if I multiply 1 by 3, I get 3, and if I multiply 2 by 3, I get 6. So here we've got B and J are similar. And then finally checking with regards to C and F. Now again, although I've only got two shapes, it's still worth just double checking to make sure that is the case. So if I take the smaller parallel side of C, that's got a parallel side of 2 and it's got a longer side of 6, and here I've got 3 and I've got 5. So you can see here that if I compared 2 to 3, that's going to give me, well, I can see straight away the fact that looking at this, I've got 2 to 3. So is 2 over 3 the same as 6 over 5? Which they're not comparable, so they are not similar. So then we move on to our last sort of shape, which is I, G and H. So again, looking at I, I'm looking at the smaller side of being 3 and the length of that being 6. I've got 2 and I'm going to have 4. And for G, I've got 2 and I'm going to have 7. So looking at I, G and H, I can see that if I multiply the smaller side, well, it's going to be by 2. So I'm getting 2 and 3, so I've got 2 over 3. And is that the same as that equivalent fraction of 4 over 6? Well, yes it is. So that means that I and H are similar and G is not part of the issue. So I and H. So what's worth doing is just looking at the fractions and writing equivalent fractions. And that's probably the easiest way of seeing whether sides are going to be similar when you're comparing the two lengths. Now if we move on to talking about the scale factors, so what I might want to do is just make a little note on the answers. So I've got D and K. So if I look at the shapes of D to K, now D to K, so if I just take one of the corresponding sides, so in terms of D to K, I've got the smaller side, which is looking at D and K. I've got the base of this being 4 and the base of K being 2. So to get from D to K, or K to D, so D to K is going to have a scale factor. So in order to get from 4 to 2, then it's half the size. However, if I want to get from K to D, then I'll need to double it. And it's always important that you know that the scale factor going from one shape to the other is going to be different, because going from D to K, I'm making the shape smaller, whereas if I'm going from K to D, then I'm making the shape bigger. Now likewise, when it comes to the other shapes, if I just have a quick move up, so I've got B and J and I and H. So let's have a look at I to H and H to I. Now I to H, again I've got the base of 3 and going from 2. So here, to go from I to H, it's going to be 2 over 3. And to go from I to H, it's going to be 3 over 2. So it's always the side in which you are looking at goes on the numerator and the end value goes on top. And that's probably the easiest way of looking at what the scale factor is going to be. And we'll talk about the scale factor in a sec. However, for the last one, in terms of the scale factor, go from B to J. So B to J, we're looking at, well, if I take the widths, which is 3, and J, where are you? Here, we're looking at 2, and a height of 2, whereas this has got a height of 3, and actually the width is 1 rather. So here we're looking at the height of that rhombus is going to go from B to J, which is going to be 1 over 3, because the width of that is 3, whereas the width or the height, depending on the orientation. So what you want to do is, so here we've got 3 and we've got 1. So B goes on the bottom, the new shape, which is J, goes on the top, and to go from J to B, and again comparing the heights there, it's going to be 3 over 1, which is just 3. So again, the main purpose of this is establishing that the scale factors can be different going from one shape to the other. It all depends on, and using your common sense, that if you're going from a small shape to a big shape, then you're looking for a scale factor that's going to be bigger than 1. If you're going from big to small, then your scale factor is going to be a number that's between 0 and 1. So it's really, really important you get that concept of just that. It's also just making a bit of a note. So if we just do a little bit of a note, and again it was mentioned earlier, so when you go small to big, the scale factor is going to be bigger than 1, and if you're going from big to small, then your scale factor is going to be less than 1. And if you can remember that, then it kind of makes sense, because obviously what you're then going to do, and what's easily done, is you can get the numbers the wrong way around. So if you remember this and don't do it correctly, at least use your common sense as to deciding which one is which. Now, as we mentioned, that also another way of looking at similar shapes is looking at the interior angle. So particularly this becomes effective when it comes to working with triangles. Now, in this particular question, what we're going to be asked to find, which is kind of missing, is state which shapes are similar. What should I say? Which two shapes are similar? So looking at this, you can see that you could be looking at the numbers, but obviously there are some numbers missing. So what we need to do here is follow the tip, which is to work out any missing angles that we may not have. So here we know that angles add up to angles in a triangle add up to 180. So if I add them up and take away from 180, I work out the missing angle here is 50. With this one, the missing angle is 40, and with this one, we get 30. So again, with similar shapes, the interior angles must be the same. So I'm looking at which triangles in question 1 have got the same interior angles, and I can see that for question 1, it's A and C. So we can kind of just cross that one off. For question 2, again, knowing that angles add up to 180, angles inside a triangle add up to 180. So here I'm going to work out and add that up, in which I get 35. Here I'm going to get 45, and here I'm going to get 90. So again, here I can, comparing the two triangles, I can see that my odd one out is B. So here the angles are A and C. I don't know why I wrote 2. Get rid of that. Say A and C, and obviously if you wrote C and A, that's absolutely fine. Now with question 3, here we can't compare the angles, however the angles are marked. Now one thing that we kind of need to spot that we didn't do with the previous 2 questions is to try and gauge whether the triangles are similar is by making sure that the orientation, or how they're shown as a diagram, is exactly the same. So what I'm going to do is, if I label these triangles A, B and C, and what I'm going to do is I'm going to redraw each of these triangles. Now your diagram definitely does not need to be accurate, as you can see from what I'm doing. And what I'm going to do is I'm going to have the single angle on the left and the double angle on the right, and both those 2 marked angles are going to be on the base of the triangle. And what I'm going to do is I'm going to relabel these triangles. So I've got A, B and C, and here I've got 9, and here I've got 6. And then for the left hand side I've got 8, for A I've got 12, and I've got 4. And for the other side I've got 10, I've got 15, and I've got 5. Now in terms of this, now as you can see straight away that I've got 2 sides that are similar, or exactly the same, which is 6 and A and C. Now I can see straight away that these 2 triangles aren't going to be similar, because the bases of those 2 triangles is the same. However, the 2 other sides of that triangle are completely different. So although 4 is double of 8, so is double that and you get 8, and you double 5 you get 10. However, the base of those 2 triangles are not the same, so A and C are definitely not going to be similar. If I then move on to, let's say, the others. Now again, what I'm going to do here is I'm going to pick, well basically from this I'm going to either have A and B are similar, B and C are going to be similar, and A and C are going to be similar. They're the 3 possible options I'm definitely going to have. Now as I've said, A and C is definitely not going to be similar, because although two of the sides are double from each other, one of the sides are identical, which therefore means it's not going to be similar. So for this, what I'm going to do is I'm going to pick two sides. So let's go for the base of the triangle, of each of the triangles, and let's go for the left hand side. Now what I'm going to do is I'm going to write these from as fractions. I'm going to have the small side at the small side on the numerator and the big side as the denominator. Now looking at A and B, we can see that from the numbers of the triangles, we can see that B is definitely bigger than A. So looking at this, if I pick those two sides, so I've got 9, which is the base on B, and we compare that to 6, which is A, and the other side we've got 8 on the smaller side, and we've got 12 on the other. Now what I want to do now is check to see if those two fractions are actually equal. So what I want to do is see if those two things are equal. Now if I simplify both fractions, which is basically what I'm going to have to do, I get 2/3, and here I divide both numbers by 4, in which I get 2/3. So you can see here that there is a very good chance that this is going to be similar. Now if I try that with the third remaining side, which is 10 and 15, so I've got 10 at the top and 15, if I simplify that, I also get 2/3. So as these three sides are the same, it means that A and B are similar. Now if I did that with, let's say, with B and C, so let me just create a bit of space by getting rid of this, and let's use a different colour. So for B and C, so again I'm going to have the small side at the top and the big side at the bottom. So with B and C, I've got my three fractions, and what we're going to do is we're going to see if they are actually equal. So looking at B and C, I've got 12 and 4, I've got 5 and 15, and I've got 6 and I've got 9. Now comparing and simplifying these fractions, so for this one here I've got 4 over 12, which is 1 over 3. For 5 over 15, if I simplify that, I get 1 over 3, which again is looking very, very promising. However, for 6 over 9, that simplifies to 2/3. So as you can see, they are not equal, so therefore B and C is not similar. So the answer for question 3 is that A and B are similar. So the question is more a question that you're more likely to get asked is to find the missing sides or lengths on similar shapes. So as an example in the next set of examples I'm going to show you, that we've been told that the shapes are similar. And what we need to do is find the lengths x and y. Now one thing that I would probably recommend that you do is make a note of this method. Now as with all my methods, they probably don't make much sense at face value, but what I will do is I'll refer to that when we're actually answering some of these questions. So if you want to pause the video and copy what's in that bubble there, and hopefully it makes a bit of sense when we go through it. Now the other thing that's worth highlighting is this formula here, and particularly this note here. Now you'll find that on different websites and different revision guides there might be certain ways, there might be two formulas that show you depending on whether you're going from small to big or big to small. However, this method is kind of universal and applies to all particular questions. There's just that little bit extra that you probably need to be aware of. So let's have a look at this question then. So the first thing you want to do is check to yourself is, are those shapes drawn in exactly the same way? Now in this particular question they are drawn exactly the same, and again the reason why I know that is because I've got the double angle at the top and I've got the single angle on the left. So then that's absolutely fine. Now the next thing I then need to do, or step 2, which is on the method, is think to myself, okay, which side have I got a number for? So if I look on the left hand side, I don't have numbers for both because I've got x on the smaller shape and 7.5 on the bigger shape, and on the right hand side I've got a 9 and a y. However, for the base of that triangle, on how it's shown, I've got 12 and 18. Now to work out the scale factor, it's basically the shape on the bigger side, which is 18 over 12. And if I then go on and simplify that, now A and B, so the scale factor of A to B is going to be 18 divided by 12, which is 3 over 2. Now basically what that means is that B is 3 over 2, or 1.5 times bigger than A. And that's basically what the scale factor does. It just basically tells me how much bigger one shape is. Now, because we're usually talking about enlargements, it's usually better to think about the big shape compared to the small shape. So obviously if I was looking at the opposite direction of B to A, then my scale factor is going to be smaller than 1, and so therefore the scale factor will be 2 over 3. So all I need to do is just flip the numbers in the fraction. Now, as we talked about, once we've worked out the scale factor, I then need to go on to work out the solution. So the solution, and it's always worth making sure you're stating what the scale factor is, which is 3 over 2. Now to work out x, I'm going from the big shape to the small shape. So for that, what I need to do is I need to do the length that I know, which is 7.5, and I'm dividing that by 3 over 2. So I'm going to do 7.5 divided by 3 over 2, or 1.5, depending on whichever you prefer, and I get an answer of 5. Now, you always got to ask yourself, does that look correct? Well, yeah, because I'm expecting an answer that's smaller than 7.5. If you get an answer that's going in the opposite direction, there is a good chance that you've probably divided when you should have multiplied, and multiplied when you should have divided. So the answer for x is 5. Now working out with y, here I'm going from the small shape to the big shape. So here what I need to do is I need to take the length of the side that I know, and this time I'm going to multiply that by the scale factor. So I'm going to do 9 times 3 over 2, or 1.5, and I get an answer of 13.5. And again, ask myself, does that look correct? Well, yes, because B is the bigger shape, and I'm looking for an answer that is bigger than 9, so 13.5 seems absolutely fine. If we look at another example, so here we've got question 2. So again, what I might want to do is redraw the triangles, because you could see that they're drawn completely different. So what I'm going to do is, if I label this A and this B, I'm going to redraw A so that it's in exactly a very similar way as it is to B. So here you can see I've got a base of x, I've got the side with the single angle is 4, and the side with a double angle is 2. And once I've redrawn that, I can kind of get rid of it, because I don't want to get the two things confused. So the next thing I then want to do is think, okay, which corresponding sides have I actually got numbers for? So on y I've got 4, 5 I've got 2, and x I've got 20. So the numbers I'm going to use for my scale factor is going to be 5 and 2. So the scale factor is going to be just that, 5 over 2, which is 2.5. Now personally, I would go for the fraction rather than the decimal, but because it is a terminating decimal, it's going to be fine with 2.5. If you had a reoccurring decimal, for example like a third, then try and not use 0.3 or 0.33. Try and type it into your calculator 1 over 3, because it makes it a whole lot more accurate. So once I've got my scale factor, the next thing I'm going to do is go on to work out the answer. So to work out x, now the corresponding side of x is 20, and then I've got to decide, well, am I going to be dividing or am I going to be multiplying? Now because B is the bigger shape and I'm trying to find the smaller side, I'm going to divide by 5 over 2. Now if I type that into my calculator of 20 divided by 5 over 2, I get an answer of 8, which again looks realistic because I'm expecting an answer that's less than 20. Now for y, again I look at the corresponding side, which is 4, and this time I'm going from small to big, so I'm going to multiply by my scale factor. And again, if you had this on a non-calculator paper, could you still do it? Well, yes, because all I need to do is multiply the 4 by the numerator, which is 20, divided by 2, which gives me 10. So then y equals 10. So it's really important you apply yourself with a common sense, because it kind of tell you when you've gone wrong or what we need to do. So again, what I'm going to do here is I'm going to pick a label, start by labeling the triangle. So let's call this one A and this one B. Now I'm going to choose to, this time I'm going to kind of draw B differently. So let's redraw B. And just to show you it doesn't really make a difference, and I'm going to first copy the diagram of A. So I've got my double angle at the top and my single angle on the left. So looking at the diagram, the side that's got both the double angle and the single angle is 18, so that's going to be 18. The side that's blank and got the single angle is Y, and the side that's got the double angle and the blank angle, which is 12. And once I've done that, I can kind of get rid of that diagram, because what I'm going to do is I'm going to compare these two diagrams together. So again, you need to find the scale factor first. So you think to yourself, okay, which sides do I have? I got a number for? Well, I've got it for 9 and 12. So my scale factor is going to be 12 over 9, which simplifies to give me 4 over 3. Now 4 over 3 gives me 1.3 recurring. So instead, I'm not going to use the decimal. I'm going to use this fraction version instead. So to work out what x is, again, I look at the corresponding side, which is 18. Now, because I'm going from big to small, because x is on the small shape, I'm going to divide by my scale factor. And again, so if I type that into my calculator, 18 divided by 4 over 3, press equals, I get an answer of 13.5. And does that look correct? Well, yes, because I'm expecting an answer that's less than 18. For y, again, I'm going for 6, which is the corresponding side, and this time I'm going from small to big, so I'm going to multiply by the scale factor. So if I do 6 times 4 over 3, I get an answer of 8, which again looks correct because I'm expecting an answer that is bigger than 6. Now, when you're doing your work, and it's always making sure, it's always important that you've identified what the scale factor is, which is here, and you've also answered the questions as neatly as you can. Now, usually in the exam, you'd have something that looks like x with a bit of space and y with a bit of space, and it may also have the units, which is something that I've probably not mentioned, but also the units aren't mentioned on the diagram, so I think I'm pretty safe. So looking at question 4. So again, if you want to have a go at these questions before I kind of spoil it and do them for you, obviously just pause the video and you can have a go at these yourself. So again, the first thing I'm going to do is label the triangles, so that's A and B. And you can see that the orientation, they're not drawn the same. So what I'm going to do is I'm going to redraw one of my triangles, and let's copy B. So here I've got the 40 on this side. Well, actually, this side is going to be it's going to be 20, and this angle here is going to be 120. So that's certainly going to help because the angles aren't double marked. So here, if we have the 40 degrees here and we have the 120 degrees there, then the side that's got 120 and 40 is 2.5. The side that's just got the single angle, which is going to be from 120 to, and this angle here is going to be 20, is 6, and this angle here is going to be x. Now for this one there is no y, so I don't need to worry about that, but what I do need to do is check to see which sides am I going to use to work out what the scale factor is going to be. Now looking at the diagram, so I can get rid of this now, and I can see that I can actually use a choice. I can either use 14.4 and 6, or I can use 6 and 2.5. Now it doesn't really matter which one you use because they both should give you the same answer. So what I'm going to go for is I'm going to go for 14.4 and 6, only because my calculator is handy. So I've got 14.4 divided by 6, which gives me 12 over 5. So then to work out x, I'm going to pick the corresponding side, which is 18. And then all I need to do is decide, am I going to multiply by 12 over 5, or am I going to multiply by 12 over 5? Now, because I'm going from big to small, I'm going to divide by 12 over 5. So I've got 18 divided by 12 over 5, which gives me an answer of 7.5. And again, does that look correct? Well, yes, because I'm expecting an answer that's less than 18. Now again, another way of checking to make sure I've got this right is, well, if I do 7.5 over 18, and I'm going to check, is that the same as, let's go for another one, let's go for 2.5 over 6. Now if I type this into my calculator of 7.5 divided by 18, I get an answer of 5 over 12. And if I do 2.5 divided by 6, I get 5 over 12. So you can see here that as these fractions here are the same, it means that my answer of 7.5 is absolutely correct. So moving on to our next example. So again here, I've got to make sure of working out the missing angles. So here my missing angle that I've got is going to be 180 minus 55 minus 65, which gives me 60. And if I work this angle out here, which is going to give me 55. So what first thing I need to do is draw the triangle so they're all the same. So what I'm going to do is I'm going to redraw the bigger triangle. So if I just call this triangle A and this triangle B. Now with this I'm going to have 55 at the top and 65 at the bottom, and this side here is going to be the 60. So the side that has got both 60 and 65 is Y. The side that has got 65 and 55 is 4.9, and the side that's got the 55 and the 60 is going to be, which we're looking at, 55 is going to be 6.3. So from this I can kind of get rid of this particular triangle. So what I'm doing is I'm comparing these two triangles here. So from this I need to find out which sides have I got a number for. Well, it's going to be the left hand side, so my scale factor is going to be 4.9 over 1.4. Now the numbers aren't nice at all, and this will definitely appear on a calculator paper. So if I type that into my calculator, I get a scale factor of 7 over 2. So to work out x, I find the corresponding side, which is 6.3. Now the next thing I've got to decide is, am I going to multiply or divide by 7.2? Now for x, I'm looking for a number that's smaller than 6.3, so I'm going to divide by 7 over 2. And if I do 6.3 divided by 7 over 2, I get an answer of 9 over 5, which is 1.8. Now if you ended up with a fractional answer, you can leave your answer as a fraction, or if you press the SD or convert to a decimal, it should be absolutely fine. Now to work out what y is, here I've got 1.3, and this time I'm going from small to big, so I need to multiply by the scale factor. So if I do 1.3 times 7 over 2, and it gives me an answer of 4.55. And again, does that look correct? Well, yes, because I know that y has definitely got to be bigger than 1.3. If I did 1.3 divided by 7 over 2, and I type that into my calculator, then what I do is end up with a number of 0.3714 blah blah blah. Now you can see that definitely using my common sense, I know that that answer is incorrect, because I know that the answer I'm looking for has got to be bigger than 1.3, because B is the bigger shape. So that's how, again, you can use your common sense to decide or to check whether you've got the correct answer. Now let's move on to our final example in this video, which is looking at number 6. So again here, I'm just going to kind of work out what the missing angles are, like so. I'm going to label this triangle B and this triangle A. So if I redraw, let's go for B. Let's just stick a B there. So I'm going to have my 111 on the left hand side. At the top I've got 28, and on the other side I've got 41. So looking at the side that's got 111 and 41, well, that's going to be 33. The side that's got 28 and 41 is Y, and the other side is going to be 39. And once I've double checked, I no longer need this diagram. So to work out the scale factor, again I need to find out which sides have I got both numbers for. Well, it's going to be those two sides here. So the scale factor is going to be 33 divided by 2.2, and if I type that into my calculator, I get an answer of 15. So basically triangle B is 15 times the size of triangle A. So working out what x is, now x, I'm going to find the corresponding side, which is 39, and x is on the smaller shape, so I'm going to divide by 15. So I'm going to do 39 divided by 15, which gives me a simplified fraction of 13 over 5, and as that's a terminating fraction, gives me 2.6. For y, I pick the corresponding side, which is 3.6, and this time, because I'm going from small to big, I'm going to multiply by 15, so I've got 36 times 15, which gives me 540. And there's your final answer. So again, just to summarise, what we need to be able to do is establish when do you recognise that shapes are similar. And again, the sides need to be of the same scale factor, but the interior angles need to be also identical. They need to be exactly the same. They don't need to increase. And then all you then need to do is, when answering finding missing lengths and missing sides of triangles, is to follow those 4 steps. So first things first is make sure that you redraw the diagrams if the orientation or the rotation is not the same. 2 is then make sure you double check the labelling of your triangle, and also try and find the scale factor. Now my personal method is always doing the side on the big shape divided by the side of the smallest, the corresponding side on the smaller shade, and then you then need to say is, okay, when I'm going from small to big, I times by the scale factor, and when I'm going from big to small, I divide by the scale factor. But again, please do encourage your common sense, because when you're writing down the answer and just typing random numbers into your calculator, it's always important you understand what your answer should look like, and I can't stress that enough. Also, make sure that although in this presentation there was no questions that involved units, so always make sure that you are writing the units at the end of your answers as well if it is applicable.